Hello everyone. So today's session we will discuss about peaking amplifier. So the peaking amplifier or peaking response, that is the frequency response that peaks a certain frequency, can be obtained by using a parallel LC network with the op-amp. So you can see here the op-amp is connected with the parallel LC network, and we will get the output as output waveform like this. We will get a peak amplitude here. So this is the peak response of the peaking amplifier. So the frequency response of the amplifier is shown in this picture. The resonant frequency of the or the peak frequency, we call it as resonant frequency, usually resonant frequency, but here we call it as peak frequency, can be obtained using the formula Fp equal to 1 by 2 pi root LC, and this will be applicable only if the figure of merit of the coil will be greater or equivalent to the value 10. Okay, so Q coil will be the figure of merit of the coil. So this is equation number 1. Okay. So the impedance of the parallel LC network is very large at resonant frequency. So therefore the gain of the amplifier at resonant frequency is maximum, hence given by the equation so it will depend on actually the gain of the amplifier is depends on AF will be depends on the resistance RF and the RP. RP is the equivalent parallel resistance of the tank circuit, and RF parallel to RP divided by R1. Okay, so we can write the gain of the amplifier as AF equal to minus RF parallel RP divided by R1. So this is equation number 2, where RP is the equivalent parallel resistance of the tank circuit. Okay, we can obtain this the value of RP directly with the equation from figure of merit. So Q coil square into R. This is the one equation that we can obtain directly from the figure of merit, and R1 here usually we will give the Q coil can be obtained using the equation that will be equal to Q coil will be equal to XL by R. Okay, so here R is the internal resistance of the coil. Okay, R is the internal resistance of the coil. R, that I will write it here. R is the internal resistance of the coil. Okay, so this is equation number 3. Just okay, now we will give the equation number it as 2 and this one as 3. Okay, this is 3. Okay, now it's correct. Okay, so Rp equal to Q coil square into R. This is the equation. And here R1 is the resistance given here, in which we can give the input signal. Okay. So the impedance of the parallel LC network below and above the peak frequency is less than Rp. Therefore, the gain of the amplifier is less than the R of parallel Rp by R1. This value. Okay. So this value we can tell the gain of the amplifier is at less than at any other frequency than Fp. So only for Fp the gain will be maximum. Any other points or after Fp or below Fp the gain will be minimum. So only for Fp the gain is maximum. That is we see in the peaking amplifier. Okay. So we can also calculate the bandwidth of the circuit. The bandwidth of the peaking amplifier can be determined using the equation bandwidth of the peaking amplifier. Using the equation bandwidth, how will we get? Yeah, using the frequency peaking frequency Fp divided by the figure of merit of the parallel resonance circuit, that is Qp. That so we will get the bandwidth. Okay, so Qp is the figure of merit of the parallel circuit so we can obtain this by R of parallel Rp divided by XL. This is the equation. Okay. And here Fp is the peaking frequency. And this is equation number 4. So this much about peaking amplifier. Next I will give you one problem according about this session. Problem 1. Okay, so the circuit diagram is already given in this figure. This is the peaking amplifier circuit. So the gain of the circuit is the gain of the peaking amplifier is done at a peak frequency of 16 kilowatts. Okay, so determine the value of all components. So using equation 1, 2, 3, 4 you can find out all the values of the circuits. So first of all, I will give you the equation for inductor. The value of inductor can be found out by the equation, peak frequency equation 1 by 2 pi root LC. So I will just write the peak frequency equation FP equal to 1 by 2 pi root LC. From this we can find out the equation for L. Okay, so L will be equal to 1 by 2 pi whole square FP square into C. Okay, so here you can give the value for FP, that will be 16 kilohertz, and you can give some value for C. So I will give you the value for C is here 0.01 microfarad, that will be better, and FP will be given. Okay, and F is already given in the question, that will be 16 kilohertz, so that you have to given to the given here. So you will find out the value for N. Okay, then Q coil can be, that figure of merit can be find out by the equation Q coil XL by R, and XL can be find out by the equation 2 pi okay 2 pi FP into L, okay, that is omega L, and by R. Okay, from this equation you will find out the value for Q coil, and RP will be obtained through the equation Q coil square into R. Okay, then you will get the value for R. Here you can substitute some value for R. So I will give the value for R, that is the internal resistance, that will be 30 ohm, and you can take some approximation for the value. If it's not 10 millihenry, likewise can give the value. If it's come to when you calculate, if it come to 9.9 millihenry, likewise you can approximate the value into 10 millihenry. Okay, always the value will be like this, the inductor's value. Okay, so you can find out the RP also. From then again, from using the equation you can find out the RF, what will be the RF will be. Okay, so for that you can you will get the equation for what will be that from the gain equation you will find out. Okay, gain equation is here, so gain equation will be AF equal to minus RF parallel RP by R1. From this equation you can find out the value of RF. Okay, from gain equation, gain of the amplifier, AF equal to minus RF by RP by R1. Okay, from this equation you can find out the value of RF. Okay, so this so you will get the all the components value of the all the components. Okay, thank you.